Okay, continuing on today with our Laplace transform playlist. We have here the Laplace transform of sine t times sinh of t dt. Now, okay, continuing on today with our Laplace transform playlist, we have here the Laplace transform of sine t times sinh of t. And over to the right, we've got a bunch of formulas we could use to help us here. And if you need some more information or background on the Laplace transform, I'll have a link in the description to the whole playlist. Okay, now this one is really similar to one I did previously. I did cosine times cosh, and again, the same problem we have here is that we're multiplying two functions. Oftentimes that's difficult with the Laplace transform. So what I'm gonna wanna do is, we have formulas for each of sinh and sine individually, but we can't really apply them directly. So what I'm gonna wanna do for this is use the definition for sinh that we have over here to break this up. And so using this formula here, we'll plug that in for sinh, and then with the minus sign, remember the Laplace transform is an integral, so we can break it up just like an integral. 1/2 is gonna be a constant, so how we'll do this is, I could take 1/2 all the way up front, and break it into two Laplace transforms, breaking it up on the minus sign, distributing in the sine of t. So like for the first one, we'll have the Laplace transform sine t times et, and then minus sign between them. The second one's just going to be Laplace transform sine t times e minus t. But then here what we can do for each of these separately, we can use this formula right here that allows us, now we can multiply because e, something with the base of e is pretty nice because we can use this right here. So getting this in shape to work with this formula, we have this coefficient here. So in this formula, our a value on this one's going to be 1. Our a value on this one's going to be -1. To use this, we need our big F value, which is just going to be the Laplace transform of this. So what we want is, in both cases, our f of t is going to be sine of t in this formula, just kind of matching it up. So for the Laplace transform of f of t, we are going to want the Laplace transform of just sine of t. Using this first formula here, the a value is just 1. So this is going to become s squared plus 1 squared, or 1, and we'll just have a 1 in the numerator. So we'll come back up here, bring down the 1/2, and then on this first one, using this formula here, what we're going to want to do is we just need to input this s minus a into this for s. So doing this, we're going to have 1 over, the s minus a here is going to be just s minus 1 plugged in here, so we'll just plug in s minus 1 squared plus 1. Do the same kind of thing on this second one. Same formula, but now the s minus a, when a is -1, becomes s plus 1 squared plus 1. And now I just want to see what simplification we can do. So I want to get a common denominator on this, doing it kind of quick. If I multiply this out, we get s squared minus 2s plus 1 plus this one is going to be a plus 2. And then for this one right here, this is going to become s squared plus 2s plus 2. And then with the common denominator, we're going to want to multiply this thing up here and this thing up here. I know I'm kind of doing it quick because I think you can see what's happening, just getting common denominators on this. So bringing this, we'll write it in this form. So we'll have s squared plus 2s plus 2. And the other one's going to be a minus on this stuff, s squared minus 2s plus 2. But then the numerator, this is going to cancel with this. 2's are going to cancel here. Then the numerator is going to become, putting these two together, this is going to become 4s. Let's multiply the 1/2 times 4s, and now we have 2s in the numerator. Then let's just multiply out this denominator, but to make it a little easier, I can write this in a way where we can use difference of two squares, because I can write it as s squared plus 2 plus 2. Because I can actually write this as s squared plus 2 minus 2s, write it like this, and then for the other one, it's going to be s squared plus 2 plus 2s. Then with difference of two squares formula, we have s squared plus 2, this piece squared minus, squaring this, we're going to have 4s squared. Then we can simplify it more. I'm not sure if I took an inefficient way here. I might have done something twice. I don't know, but I don't care that much. So let's just do it. So then here we're going to multiply this out. We're going to get 2s squared plus 2s squared is 4s squared. And then plus 4 minus 4s squared. I kind of missed this in the previous video. I kind of missed this part in the previous video. I didn't simplify it all the way. And so now I'm kind of correcting my mistake in a way. So Now the 4s squareds are going to cancel here, and so for my final solution is we just get 2s over s to the 4 plus 4, and that's it. Okay, there you go. Laplace transform sine t times sinh t. Thanks everyone for watching. Have a good day.